In this video, we're going to look at a specific type of limit problem that's going to become very important in the future of calculus for us, and that's the limit of the difference quotient. If you want to see more things about what's going to be eventually called the derivative, look for a later video where I tie that in. But for now, we're just going to consider this on its own. So, limit of the difference quotient. Well, first off, let us recall that the difference quotient for some function f of x will be f of x plus h minus f of x all divided by h. And this can be used to find average slope. Now, looking a little bit ahead, what we're going to eventually get to is something called the derivative. So I'm going to put in a little spoilers. The derivative f prime of x will equal the limit as h goes to 0 of this difference quotient. Now, what is the derivative? What does it find for us? Why does doing this limit get me there? We'll answer those in a later video. For now, let's just consider this limit as a neat little limit problem that we can do. So let's see one example to get a handle on how to do this. And I want to, in this, evaluate the limit of this difference quotient as h approaches 0. So I will find the limit as h approaches 0 of f of x plus h minus f of x all divided by h. And that's going to equal the limit as h approaches 0 of, I'm going to put all of this into there, so let me do some coloring here. So I will have x plus h squared minus 3x plus h plus 2, so that's this portion, minus, and then I'll do this portion, which is just f of x, so I have x squared minus 3x plus 2, all divided by h. And as we saw, this is not continuous at h equals 0, which is where I want to try to evaluate this limit. So I have to do some work before I can evaluate it analytically. And so how it's going to work for a lot of these is I'll expand out this portion of it and get the limit as h approaches 0 of, this portion expands out to x squared plus 2xh plus h squared minus 3x minus 3h plus 2. And this portion I'll distribute through the negative sign and get a minus x squared plus 3x minus 2. And still, I cannot just evaluate this at 0. It's not continuous. It's undefined at 0. But I can cancel out some things. So the x squared minus x squared cancels. Negative 3x plus 3x cancels. And 2 minus 2 cancels. And all I'm left with now is this. The limit as h approaches 0 of 2xh plus h squared minus 3h all over h. And I can cancel out the h's. Now, if you see I have h's in each term, I can just cross off a single h, or I could think of factoring an h out of the numerator. So I have limit as h approaches 0 of h times 2x plus h minus 3 all over h, and you'll see that these cancel. The same way that I could cancel out a single h from every term here. They both work the same way, which is going to equal the limit as h approaches 0 of 2x plus h minus 3. And you might be wondering, well, hold on here. This fraction with the h over h is not equivalent to this expression at h equals 0 because this one is undefined, 0 divided by 0. This one is defined at 0. But that doesn't matter because the limit never is going to get to h equals 0. This is continuous. As h approaches 0, this function approaches 2x minus 3. And that is the limit of this difference quotient. If there are any questions, please feel free to comment below. I hope this helped you guys out.